Alright, so today I want to talk about arithmetic sequences. Now, when we look at this topic, there are two parts here. The first part being the word arithmetic. Now, arithmetic we can associate with the words add or subtract, while we associate the word sequence with pattern, a pattern of numbers. So let's just take a look at a couple sequences which have patterns, and we can determine if it's arithmetic or not. So example 1, we have the following sequence. Okay. Now, when looking at this, we want to determine, is there a pattern from when we go from the first number to the second to the third. So if we're looking at this problem here, you want to think to yourself, how do I go from the first to the second? And the easiest way to do that is to use A2 minus A1. Now what this does is it's the difference between the two terms. So if we do 2 minus 1, we get the number 1. So the difference here is 1. And we want to check, is the difference between 2 and 3 1? And I put plus 1 because we're going up. And then this is plus 1. So 1, this is a sequence because there's a pattern to these numbers. 2, it's arithmetic because of these key words here, add or subtract. In this case, we are adding plus 1 each time. Okay, so this is an arithmetic sequence. Alright, now but let's look at a different example. If I look at this example, 1, 3, 6, 10, 15. Well, let's see if there's a pattern here. If I find the difference of these two, 3 minus 1 is plus 2, 6 minus 3 is plus 3, 10 minus 6 is plus 4, and 15 minus 10 is plus 5. So if you notice, there is a pattern. We're increasing by 1 more each time. I increased by 2 here, I increased by 3. So this doesn't add or subtract the same number. We are adding a number, but it's not the same. And the key to arithmetic is that you have the exact same difference. So in this case, this would not be arithmetic because we do not have the same difference, or the same difference here. Okay, so this is not arithmetic, but it is important that you understand, even though this is not arithmetic, it is a sequence, okay, because it does have a pattern to its numbers. Alright, so once you realize how to find an arithmetic, which is by finding a common pattern, okay, here's plus 1 plus 1 plus 1, and common, by common I mean it has to be the same, then you can start working with the formula. The formula for arithmetic sequence is A sub n equals A1 plus n minus 1 times d. Now, it's one thing to see a formula, be able to use the formula, but it's another thing to understand each part. So in order for us to gain a good grasp on what this means, we're going to write down the definitions of each one of these. So an is the value of the nth term. Now we say nth because this letter right here is an n, so that's the term we're looking at. This could be like the 5th term, which in this case up here, this would be 15. Or if we're looking up here, we say the 3rd term, which we just count 1, 2, 3. This will be the 3rd term. The value is 3. Okay. A1, which would be the value of the 1st term. Okay. So if I'm looking up here in the previous examples, if I were just speaking of terms in general, this is the value of the 1st term, 1, and then also this one had the exact same value. Now n is the term. Now when I say the term, I'm talking about counting. Like up here, I could say 6 is what term in the sequence, and we could count 1, 2, 3. So 6 would be the 3rd term. And then we have d. D is the common difference. So this is where you have to find that difference between each number in the sequence, but common, which means the same. So like here, plus 1, plus 1, plus 1. This would be your common difference because it's the same difference over and over. Okay. All right, let's try a couple examples using the formula. So the first thing we're going to do is we're going to actually find the value of a term. So I want to find the 50th term. Now, a little thing to remember that will help you know when to use n and when to use an is that anytime you have th, rd, or nd, this refers to n. So it's just something small, remember, because it's counting. Like if you're in 4th place, that means you're the 4th person to cross the finish line. So that's one way to remember that this is counting. Okay, so here's my sequence. And we're going to use the formula. So I'm going to rewrite the formula here so we can all see it at the same time. And we're going to label things one. Now that we've realized that we're finding n, you can find any of these four. I can find an, a1n, or d using this formula, just depending on what's given to me in the actual sequence. But since I'm given the first term, I know I'm not going to find a1. Okay, I'm given n, so I know I'm going to find n, and then I can always find the difference if I'm given two consecutive numbers in the sequence. So we know that a1 is 4 because that's the very first term in the sequence. We know n is 50, which is given to us from the question, and then we know d, which is the difference. Now keep in mind, if you can't see the difference, which not everybody can, use the little bitty formula a2 minus a1 to find that. So in this case, that would be 8 minus 4, which is 4. So our difference would be 4. Now, once you have these figured out, all we're going to do is we're going to take these values for a sub 1, n, and d and substitute those into our formula. So here you see it's a sub n. Well, we know n. That's 50. So a sub 50. We know a1 is 4 plus, and then we have 50 minus 1 times 4. Make sure when you're working this out, if you have the formula to look at, make sure your equation you've written looks just like the formula. So if you notice, I have one value on the left, I have a number, then a plus sign, parentheses, a number, a subtraction, a 1, and then I always put this number in parentheses because if and when we get to negatives, we don't want to accidentally mistake this as a minus 4. And we'll do an example in a minute just like that. Now, the good news is if you have a calculator, then you can actually take this and put it into your calculator and allow it to compute it for you. And if you do that, you are going to come up with 200. Now, being able to find this number is great, but knowing what the number means is even better. So this value here, this value is the 50th term of the given sequence. It is important that you understand that this is the value of the 50th term. This isn't the 50th. This isn't saying I'm going to add anything up. This isn't saying that I'm looking at the 200th term. This is the value. If I were to extend out my sequence, when I mean extend out, I mean to continue with the pattern like this. Then when I got 50 terms, so if I counted them, on my 50th one, that value would be 200. Okay? So really, it's not truly difficult if we can substitute and understand what we are finding. So let's try one more example. And this is one that deals with negatives, because a common mistake that happens is that people forget that we're multiplying instead of adding or subtracting. So they'll find the 112th term of -3, -8, -11, ... Now, let's do the same thing as before. We know what we're actually looking for here. We're looking for the a sub n, the value of a term. So we know n. It's great to actually go through and say what each piece is. This way, when you substitute in, you know what you want to substitute in, so you can tell if you did it right or wrong. So n is 112, a1 is 3, and then we'll perform. This one's a little harder because some people think these numbers are going up, but in reality they're going down. Because the larger your negative gets, the smaller the number is. So let's go ahead and use our little rule, a2 minus a1, to help us find d. So we got -8 minus -3. Okay. If you have a hard time doing these basic computations, it's okay to use your calculator to help you there. But if you don't, that's fine. This is going to turn into a plus because subtracting a negative, that same sign, that means it switches. So it's actually -8 plus 3. And I just like to go through and do that if I'm working by hand. And that's -5. So we have a1, n, and d. So let's take our formula. Okay. So I'm going to write it down here again so that we can take a look at it. It's nice to understand the formula and to know what it looks like. Because if you know what it looks like, then you can fill it out easily. So an, we know n is 112. So right now we are looking for the 112th term. a1 in this case, if you notice I forgot my negative there, it's -3 plus, we know n, that's 112 minus 1, and then times d, which in this case is -5. Now from here, it's really simple. All you have to do is take these values. And this one you're probably going to have a lot harder time if you were doing this by hand, and you might not be able to figure out this term. Because it's 111 times -5. So you might, but it might take more time. So to be more efficient, you want to use your calculator to determine what this 112th term is. And if you put in the calculator, you do get -558. Now, like we said before, this is the value of the 112th term. Now, what I would like you to do is I want you to take this next example, and I want you to figure out how to work it on your own. So keep in mind, this one's going to be a little bit different, but think about what each piece means, and you should be able to figure this out. If you have questions, I'll be happy to come by, and we'll see if we can figure it out together. So here's your question, and I'll give you 3 minutes to work on this, and then I will walk around, check as I go, and then we'll talk about it once we are finished, okay? And there's your sequence, so go ahead and get started on that.